So here's some notation that we're going to be using. These are called factorials. So if n is a natural number, then we'll define n factorial. So it's written as n with an exclamation mark after it. That's defined as n times n minus 1 times the next number all the way down to 3 times 2 times 1. And we'll define 0 factorial to be 1. So you read this thing as n factorial. Here are some examples. If I want 5 factorial, this is 5 times 4 times 3 times 2 times 1, that would be 120. If I want 3 factorial, that's 3 times 2 times 1, that would be 6. If I want 6 factorial, that's 6 times 5 times 4 times 3 times 2 times 1, that's 720. So we're going to have a couple of counting techniques. One of those techniques is going to be counting things called combinations. So here's the definition of a combination. Let's say that X is a set. We'll say that C is a combination of X with size K if C is a subset of X and the number of objects in C is K. So C is a combination of X with size K if C is a subset of X that has K objects in it. If I want to talk about the set of all the combinations of size K, I'll write down something like this. So let's say X is a set. I'll define the combinations of X of size K to be all the combinations C, where C is a combination of X with size K. Here's an example. Let's say X is a set of letters A, B, C, and D. Then the combinations of size 0 of X would be all the subsets that have exactly 0 members. There's only one subset like that. That's the empty set. So here's the set of all the combinations of size 0. There's only one combination of size 0, and that's the empty set. If I want all the combinations of X of size 1, this would be all the subsets of X that have exactly one member. So here are all the subsets of X that have exactly one object. If I want the combinations of X of size 2, this would be all the subsets of X that have exactly 2 objects. So I've listed out all the subsets of X that have 2 objects. If I want the combinations of X of size 3, that would be all the subsets of X that have exactly 3 objects. So I've just listed out all the subsets of X that have exactly 3 objects. If I want the combinations of X of size 4, this would be all the subsets of X that have exactly 4 objects. There's only one subset like that, and that's the entire set X. So here's the basic fact we'll use to count combinations. So if the number of objects in X is n, then the number of combinations of X of size K is given by this formula. So you take n factorial over n minus k factorial times k factorial. This fraction shows up so often that there's a special notation for it. So here's that notation. We'll define n choose k to be this fraction. Okay. So some people call this a binomial coefficient, and we'll read it as n choose k. So if you see this notation here, it looks a little bit like a fraction, but there's no fraction bar. You just have these numbers stacked, and then you have parentheses around them. When you see that, it just stands for this fraction over here. N factorial over n minus k factorial times k factorial. There are some alternate notations for this. So some people just write nck instead of this binomial coefficient. Some people write cnk to stand for the same thing. So these all mean the same thing. Here's an example. Let's say X is the set of letters again, A, B, C, and D. If I want to count the number of combinations of size 3 of X, this would be 4 choose 3. There are 4 objects in X, and I want to count how many subsets there are of size 3. So you do 4 choose 3. It stands for this fraction here. You could work out what this is. So 4 minus 3 is 1. So this would be 1 factorial there. I've written out what 4 factorial is. So here's 4 times 3 times 2 times 1. 1 factorial would just be 1. 3 factorial is 3 times 2 times 1. And this would simplify to 4. So there should be 4 combinations of X that have size 3. And if you look back at the combinations of X of size 3 that we wrote out, there were 4 subsets like that. Here's another example. Let's say X is the set of letters in the alphabet. So I've got all the letters in the alphabet here. There are many ways that I could choose 5 letters. So here are some possible ways I could choose 5 letters. I could do A, B, H, L, R, or C, J, M, P, T, or K, M, S, U, Y. So there's a bunch of different ways I could take 5 letters here. I want to know how many ways I could do that. So how many ways can I choose 5 letters? So what I'm really trying to find is the number of combinations of those letters of size 5. This will be the number of ways I could take 5 letters from these set of letters X. So there's 26 letters. I want to choose 5 of them. So this is 26, choose 5. Here's the formula for that. Just plug 26 and 5 into this. So this will be 26 factorial over 21 factorial times 5 factorial. I just wrote out what 26 factorial is up here. I wrote out 21 factorial here. So here's 21 factorial. And then I wrote out 5 factorial. Here's 5 factorial. Now some of this stuff is going to cancel out, and you'll end up with this on the top and this on the bottom. And you could simplify this. It'll be about 65,000. This is the number of ways I could take 5 letters from the alphabet. If you want to find N choose K on a calculator, you'll probably have a button that looks like this, maybe NCK or NCR. So you'll have a button like that on your calculator. If you want to find 7 choose 3, you'll type in 7, you'll hit this button, it'll be somewhere on your calculator, then you'll hit 3 and hit equals, and that should give you 35. So you could find this on a calculator easily. You don't have to plug these numbers into the formula. You could just use a calculator here. So here are some examples where you count how many ways you can do something by using combinations. Let's say there are 9 books. I want to know how many ways I could choose 2 of those books. So this is just 9 choose 2. You could type that into a calculator or plug these numbers into the formula for 9 choose 2. You should get 36. This time there are 34 dogs. I want to know how many ways I could choose 5 of those dogs to take home. So this is just 34 choose 5. So you could type that into a calculator. It's almost 300,000. Now I've got an urn that has 8 balls. I want to know how many ways I could take 4 of them. So this is just 8 choose 4. There's 8 balls and I want to choose 4 of them. So you do 8 choose 4. That'll be 70. Now an urn has 5 balls. I want to know how many ways I could take 5 of them. So this is 5 choose 5, and that should be 1. And that makes sense because if I have 5 balls and I want to know how many ways I could take 5 of them, there's only one way I could do that. I just take all 5 of the balls. This time an urn has 27 balls. I want to know how many ways I could take 1 of them. So this is 27 choose 1, and that'll be 27. That makes sense because if I have 27 balls and I want to know how many ways I could take 1 of them, there's 27 different ways of doing that. Because I just take 1 ball and there's 27 balls. This time there are 8 football teams. Each team must play all the other teams at least once. I want to find the number of games that must be played. This is going to end up being 8 choose 2, which is 28. So you could think of it like this. You'll have a set of 8 teams. So I'll write T for the set of teams. I'm just going to call the teams Team 1, Team 2, Team 3, and so on. Think of a game as a subset of T that has 2 members. For example, this subset of T, 3, 7, you can think of that as the game of 3 versus 7. And the order doesn't matter here. So the game 3 versus 7 is the same as the game 7 versus 3. So if I want to count the number of games I could form, I'm just going to count the number of subsets of size 2 I could form here. And the number of subsets of size 2 is going to be 8 choose 2. Now I've got 18 people at a party. Each person must shake hands with all the other people at least once. I want to find the number of handshakes that have to occur here. So this is going to be the same type of thing as the football problem. So it's going to be 18 choose 2. That'll be 153. That's the number of handshakes that'll have to occur. So think of the set of people as the set P. So I'm going to call the people 1, 2, 3 up to 18. So you have person 1, person 2, person 3 up to person 18. You can think of a handshake as a subset of P that has 2 elements. For example, the handshake between person 4 and person 13 would be the set 413. So if I want to count how many handshakes I would need, I'm just going to count the number of subsets I could form of size 2. So the number of subsets here of size 2 would be 18 choose 2, and there's 153 of those subsets.